I say to you now, I am about to resume my Arduino electronics project. Yes, you heard correct. We're talking soldering, we're talking cutting wire, the whole thing. Now, for those of you who don't know what project I'm involved in electronically, which has been put off for the last 4 months or whatever since I last worked on it, I'm connecting one Arduino to an ATMEGA 328P microcontroller. That's the same microcontroller that powers Arduinos. Arduinos are just breakout boards that just give you header pins coming out from the microcontroller. And it also gives you a USB interface to the microcontroller so that the computer can talk to the microcontroller, and a couple status LEDs, quartz crystal resonator, and a power plug and a USB plug. But for a project that needs to be small, or for a robot project where you don't need a prototyping board, you just need the microcontroller. You just want to strip it down to the bare essentials. You have to learn how to program just the microcontroller by itself. And you use another Arduino to program your microcontroller. So I'm going to connect an Arduino to an ATMEGA 328P microcontroller through a series of wiring, and then I'll be able to use the Arduino, talk to it with my computer, and tell it how to bootload the ATMEGA 328P microcontroller. Now, bootloading it basically just means installing like an operating system on it, and then once it has the operating system, then you can talk to it in a way like uploading programs to it. The programs are called sketches, but it needs the operating system first. So basically I'm installing an operating system on a microcontroller, which is like a mini computer inside a little chip. It's got RAM, it's got memory, it's got hard drive space, it's got everything. It's got timers. I mean, it's a full-blown computer in a tiny chip. So there's actually a lot of wiring involved in doing this, and it's taken me quite a while so far. I can show you here this is the wiring diagram. So you've got your Arduino board here, and you got a series of wires coming off of it, drawn in my fancy way, how I like to draw. And they all end up here on this microcontroller, which I've labeled every pin on. And you got your resonator and 2 capacitors, you've got a resistor here, but that's all discrete components. And I've almost finished all of this. So maybe today I'll be able to finish wiring it all up and I can install the bootloader to it. It's possible. I don't know. I mean, I don't even remember fully which parts I've already installed, but I do know this. I have every part I need for sure. I bought about 20 of these quartz crystal oscillators, 16 megahertz. These are little timing crystals which make your Arduino chip. I call it an Arduino chip, but it's not an Arduino chip. It's an ATMEGA 328P microcontroller created by ATMEGA, who is a company that makes microcontrollers. Arduino is just the name of an Italian company that built this development board around this chip. I could make a development board around this chip myself. Anybody can do it. But they just got big because their board is really simple design and it's just caught on with hobbyists. You don't actually need that board. All you need is a microcontroller. And you can use any microcontroller, but ATMEGA 328P microcontroller is so popular because it's associated with Arduino. And you can use it with Arduino's development software, their IDE, to make sketches or programs to upload to your microcontroller. So it's smart to use the microcontroller that's so well supported through the Arduino following or community, so that you can solve any problems and have questions answered in their forums and stuff like that. So that's why I chose that as my microcontroller. I'm going to have like 50 to 100 of these microcontrollers in my robot, and they're all going to communicate to each other through a network. So the computer will connect to USB to the first one and talk to it, and then the first one will talk to 6 more, and then those 6 will each talk to 6 more. So it will be a communications pipeline, so that ultimately my computer can communicate with all 100 chips all through one USB cord. Unless if it ends up being faster to to get a USB breakout board and try to connect USB to every Arduino, but that's a lot of USB cable, whereas the cable running from one Arduino to another is just like a tiny little cable, whereas the USB cable is pretty thick by comparison. So I'd rather just have a communications pipeline with the only involving one USB. But we'll see. I mean, I could try different configurations. I could try like 5 USBs leading to 5 microcontrollers, and then those microcontrollers each lead to 5. So then that would give me 25 times 5, 125. So yeah, I could have 5 USBs that way. So it's kind of a compromise. But we'll see it. We can compare benchmarks and stuff as far as how fast the different communications protocols are. So yeah, the project I'm working on is just to get my first microcontroller bootloaded and then run programs on it. And then once I have a working microcontroller, I'm going to need 2 of those for my vacuum power supply project. My DustBuster vacuum power supply is something I designed from the ground up. All the circuitry, all the schematics, I designed it all. And it's my first time. I'm converting AC from the wall into usable DC that will power the vacuum and also charge the batteries. And I created and designed my own balance charging system for the batteries as well, which is superior to commercially done balance charging. It's more efficient and faster. It's really cool. It's going to require some tinkering though to make sure that my theoretical designs actually work out correctly. I have to figure out the timings and stuff in order to generate the right voltages and whatnot. So that's going to be a major project, but that power supply project, even though it's way beyond what anybody would normally do for their handheld vacuum cleaner, I'm going the extra mile because it serves as a prototype for my power supply design for my robot. So by being able to create this power supply from the ground up for the vacuum, I'll be all the more prepared to create an even more sophisticated power supply system and battery management system for my robot. So that's why I'm willing to put this much time into a power supply for a handheld vacuum, a Black & Decker. So anyways, that catches you guys up on what this project's about, and now we can get to it and see where we left off in this wiring. We're doing this wiring that I did in Photoshop here, and it says burning bootloader onto ATMEGA 328P microcontroller chip using an Arduino board. This drawing we're now putting into real life. So I gotta find where I put that stuff. Here it is. See guys, I'm very organized. Haven't worked on 4 months and I went straight to where it was on my shelf because I know where everything is. People say I'm unorganized and they're wrong. If I was unorganized I would have spent, you know, a day looking for where I put something that I haven't worked on in 4 months, but I knew. That's proof I'm organized. So I just pulled out my Arduino. It's so beautiful to look at. This is an Arduino Uno. It's basically a clone of the Arduino, the classic, created by the Italian company. It does the exact same thing, and it's only like $3. But what's great is that these are only $1. They're down to $1. When I bought mine, they were like $2.13. They're $1 now. They're just getting ridiculously cheap. Next, they'll be 50 cents, and they do everything that this board does. They're so cheap. Electronics is becoming ridiculously cheap, guys, because there's so many people into it now, and the Internet of Things has started. Everything's becoming economies of scale. Everything's so cheap. Now's the best time in the world to get involved in this stuff, because it's so inexpensive. There's nothing holding you back. Orange Pie is 20 bucks. That ain't nothing. This thing is like $4 and it does the same stuff. Yeah, the Orange Pie might be, slightly faster, big deal. That's why you use 50 of these. I mean, that's why you use 50 of these tiny microcontrollers. 50 of these would be worth 10 Orange Pies or 20 of them. And they're only 99 cents or like 80 cents. You can use as many of these as you want. There's no reason to buy a pie, any type of pie. Those days are over. Oh, okay, it's upside down. Okay. This is looking good, guys. I'm figuring out where everything goes so far. Um... Whatever that means. I don't even know what neutral means. I thought you were gonna go get ready. No, I didn't say that. I said I'll be back. I didn't even say what I was gonna do, did I? I took a wet wipe shower while I was gone. Oh my gosh. You son of a bee. I'm putting flux on stuff now. Perfect. Oh, now I need my helping hands. I can't do crap without helping hands. What am I making? I'm not making anything. I'm just connecting one microcontroller to a microcontroller development board with the aim of installing the bootloader onto the microcontroller I'm connecting the development board to, because it has no bootloader. My room's pretty well ventilated, so I'm not too worried about inhaling a little bit, but I try not to inhale it too much. Usually I blow on it if I'm starting to notice, but already the solder had burned off when I tinned the iron, so when I put it near my face I didn't get a whiff of anything. Okay, this goes here, right? Yeah. What is this here for? Nothing, that's what. Okay. Well, I'm ready for another signal wire then. Using up my jumper wire pretty fast here. Need a longer one. It's alright. I don't need that much jumper wire. Alright, this one goes to 12 to 12. Whoops. You were my 13er. 10er? 13er. You're my 12er. I already know why you asked what am I making. You wanted me to say bomb, and I didn't fall for it. As much as you try to bait me. Because people won't think that's funny. In this day and age, people would take me very seriously. So I don't joke that way. You know, I actually could make a bomb, I think. I mean, the world's leading roboticists can make a bomb. I never even realized that I can make a bomb until just now when I thought about it. I'm like, I can do all this stuff? Yeah, bomb making is way less complicated than the stuff I'm into. No, I'm not using Arduinos for servos. I'm using them for... Well, okay, I'm not using Arduinos at all in any of my projects, except to help me program microcontrollers. All my projects will only be using microcontrollers. What the heck? Raspberry Pi, Arduino, Orange Pi, any type of those are development boards. Development boards take a microcontroller of some size and then add a bunch of periphery elements to make it easy to plug and play with these headers on the sides. All I need is the chip, and I can solder directly to the microcontroller, and that lowers the lowers the amount of space taken up, which makes it able to be fit into smaller spaces and use more of them. So more processing power in a smaller space, that's the goal. We don't need this big circuit board, wasting a lot of room. Didn't seem like it pushed all the way into there, but I guess it did. I guess it did. It just doesn't look like it's all the way in. You can see all of these still have metal showing, whereas the one on the top doesn't. So I don't know why most of them aren't pushing in all the way, but I don't want to try to force it. As I already told Mailbox, but he doesn't listen. This is the easy part. I already did the circuitry research. I already know where all the wires go. I'm not doing any thinking right now. All I'm doing is just connecting wires to wires according to the diagram I'm looking at on my computer. Each time I'm putting on Kester 186 no clean flux, which is so incredibly awesome, by the way. Oh, that's right. I gotta... Alright, so what I'm finding works the best is just load up a soldering iron with solder, and then stick that onto the two surfaces to be mated. I'm being picky, but I just don't like how that one went on. Oh my gosh. Perfect. Of course I'm gonna solder over my stomach because it's all ergonomic. It's just like a rat. Like, look how my arms are. They're like little rat arms, or a T-Rex. elbows at my sides, arms working right close to my eyes so I can see, and I can lay in a reclined position this way. Otherwise, in order to have my arms in an ergonomic position and my eyes close to my work area, I'd have to be hunched over a table, which would be horrible for my back. Right now, I could not be more comfortable. This is how everyone should solder. No exceptions. Or you'd have to have like a really tall table, I guess. That's right up by your eyes, so you don't have to bend down to see. Thank you for saying I'm awesome, Warp Smoke. Okay, so 4 going to here. I got those. They all went to here, I believe. Let's see. 1, 2, 3. Oh, this one didn't. This one didn't. Okay. 1, 2, 3, 4. One more comes off, which is the ground. Okay, so we gotta think about the ground now. Well, let's see. I can just take a big ground wire for now and just throw it in, because he's gonna, let's see. Well, I actually don't want to take it off the helping hands right now because it's easier just to leave the helping hands in place. So this ground will come out here. Let's just plug it in. Oh. Alright, I think you have to pre-score it if you want to split it. I forget how I did this in the past. There. That's what I wanted to do last time. Oh crap. I'm gonna start pre-scoring everything because otherwise this thing can tend to break it off. There. Come on. It's never gonna happen, Pix. Alright, so this goes here. My soldering iron's 842 degrees. Alex, nothing's ruined. I'm a master roboticist, the world's leading scientist. I don't ruin anything, ever. My goodness. This is about to get cray. Okay, we need one long one to attach to this. And then that one will branch off twice. Guys, how would you label the wiring? You're supposed to label everything. Do you label it at the end or as you go? I guess masking tape might be good. You just fold it in half and then write a little number on it. Why the hell do I have 2 viewers right now? My dashboard must be broke. Do I actually have 2 viewers? Because you guys complain all the time you never get to see any real robotics or electronics. And then when I do it, I get 2 viewers? Really? You guys should be thanking me right now for making your dreams come true. And that especially applies to you, Mailbox. Mr. I want to see the robot being built. Mr. I'm just here for the electronics. Why did you say wow, mailbox? Did I just do something impressive? We all know you would never admit it if I did something impressive, mailbox. Just admit it, mailbox. I'm better than Lewis. You know you want to. Dang, this soldering stuff gets easier and easier. Once you figure out, like, better techniques. Guys, I'm flying through this. Like it's nothing to me. When are you all gonna realize that I'm the real deal? When will you all admit I'm the world's leading roboticist? I don't have a chipmunk voice. I just didn't finish the laptop. How'd I ruin it? I set that job aside for the time being. Alright guys, let me just show you how I did this capacitor. Um, so I just I just cut the wire with the X-Acto knife and pulled the sheathing apart to expose just the wire in the center. And then I just soldered the ceramic capacitor onto the wire with the wire as a single strand. Now I'm going to cut out the center. Just leaving wire with the gap in between, because I can't have electric flowing through like that. It has to go through the capacitor only. So there's how it looks afterward. Pretty cool, huh? How was that mediocre? Looked perfect to me. Oops, I did it again. Another perfect joint. Got lost in the soldering. Oh, baby, baby. Oops, I think I'm a great roboticist. This thing won't fall apart. I'm just that good at robotics. It's not Adam's brain. Thank you, Dimebag. Guys, I am going to be able to finish this today. They can't put a head on another body. If I see one resident sleeper, I'm going to go nuts, because this is what you guys all signed up for. This is real robotics right here. So if this won't do it for you, I don't know what will. Mr. Dimnas, I'm telling you, Affiliates on Twitch do not get to make sub badges. That's only for partnered streamers. I'm not partnered. I don't make sex toys. And I haven't neglected you. I'm just... Hey, you guys were annoyed with me that all I did is video editing. Well, I had to catch up. So I've been kind of no fun in games lately, I'll admit to that, because I'm a man on a mission. I'm trying to get back to entertaining stuff like working on the robot. I've been so caught up trying to just get organized again after the marriage. There's a lot of disorganization that happened. No, I'm not making an electric shaver. I'm not a bomber. This becomes software at this point. I think I'm done with all the hardware. Which is crazy. I didn't know I'd get this done today. I told you guys I might. I didn't know I would though. I first finished Mega Step. It's awesome.
Yeah, the board's already set correctly. Okay. Select your serial port. Select your serial device with Arduino board controls serial port menu. It's likely to be count 3 or higher. Okay, mine's count 6 as you recall from right here. By the way, this board shows up as USB serial CH340 count 6, and it's Arduino and Arduino. It should be called not real Arduino. Okay, so tools, port, count 6. Now let's click the upload button in the environment. Wait a few seconds, you should see RX and TX LEDs on the board flash. If you upload upload is successful, the message done uploading will appear in the status bar. Upload.
Okay guys, I'm uploading the Arduino ISP program, so I imagine Blink would stop running, so the blinking light I'm used to will no longer be there. Oh snap. It's not blinking anymore, guys. Done uploading. Sketch uses 4380 bytes, 13% of program storage space. maximum is 32,256 bytes. Global variables used 481 bytes, 23% of dynamic memory, leaving 1567 bytes for local variables. Maximum is 2048 bytes. Done uploading. So we have the Arduino ISP on our Arduino. I didn't show my lab point of view because the only difference is the blink program, which was flashing on here, is no longer flashing. There's now a steady light. Well, two steady lights. One is the on light and one is just the L LED. It just says L next to it. Alright, so we did this step. Okay, Guys, I burned the bootloader! Guys, it worked! Do you realize what we've done? This is how I know it's worked. It says right here, done burning bootloader. Baby, they saw you! Shh! What's next? I can't believe I did it. I'm not a fraud. Shh. Ow! The instructions on Arduino's website were crap. Are the instructions on arparobot.com? No. Though, I mean, this video will be the instructions. I don't really do, like, note-taking on my website. I have my own notes, and then I have my video notes. I get paid for video notes. If I put my notes on arparobot.com, I wouldn't get paid a dime. So that's kind of like just press releases. That's not really where the meat of the knowledge is. I can unplug this now, knowing everything's still okay. My idea was to use my 3D pen to secure this wiring setup into position, into the position it's in, so that I don't have to like figure out where all the wires go again when I unsolder this all from the microcontroller. These wires would all be, their configuration would be lost. And I want to be able to use this thing for the next microcontroller I do. So I want to like lock it all into the position it's in. Okay, that was a fail. Okay, so I got all these kind of just locked into place now. Basically, I just use my 3D pen as like glue. And then I'll just do the same here, lock all these into place. Okay. And then, most importantly, I want to lock these bad boys into their places. Hmm. Alright, so I just like loaded up molten ABS all over the wire ends so that they maintain their uh, spacing, so that when I desolder it from the microcontroller, I can just pull them all off and then just solder them all back on, and I don't have to remember what order they were in or anything. And here's the other side. Doesn't want to focus. It's annoying. There we go. So yeah, we can just desolder them all now without worrying about the order, since the order is dead on. Kind of just locked in what we needed. It's gonna be super easy now. Whenever we wanna do the next one. Yeah, I could have numbered the wires, but you're still having to match number with number and blah blah blah. This is a lot better. I mean, basically now the whole wires are like a pack. And I can just line it up. Boom. That's way easier. And the same with these two. Boom. So that's how easily now we can, like, everything's plug and play. And this will be plug and play in the future. I'm going to get a socket. It's called a dip socket. 28-pin dip socket that these microcontrollers can plug into. It's like got two channels that you could just plop it right in. So when I desolder all these, I'm going to solder them into a dip socket, and then whenever I want to program one of these microcontrollers, I just plug this in and then plug these two things in to this board, and boom, click burn bootloader, and we're done. So it's going to be all plug and play. No more, like, this huge soldering job is a one-time thing, and I'll be able to do all my microcontrollers super fast after this. This is like a one-time setup. So that's why it was worth it to take forever. And I didn't have to do it on a development board or make a circuit board for it or anything. I like dead bug style. This is called dead bug style. It's like this is the body of a bug and this is like its legs. It looks like a weird alien bug, like a creature. Iskapig, you know what a dip socket is? What the heck? I mean, I guess a dip socket is basically like the same as these headers, except they're like running next to each other or whatever. Like closer. Like these are too far apart for a chip, so I need something like close together. But yeah, actually these are like jumper headers. You're supposed to plug jumper cables in like we were here. But what I bought is specifically made for sticking in microcontrollers. And I guess what people do is they put different programs in different microcontrollers and they just snap it into their Arduino and it runs different stuff to save time. So that's why they made those. But normally you would solder in your microcontroller directly onto your board. But I guess those sockets just make it a little easier to swap out microcontrollers if you burn one out or something. I don't know. So, what is next? So now we're back to here. Uploading programs from Arduino board to ATMEGA 328P microcontroller chip. That's a whole different beast. Remember to remove the microcontroller from the Arduino board first. And that is important. But I have to pick which board I want to butcher like that. You know what? It should be one of the boards that doesn't have a bootloader on it. Because that's already less valuable to me not having a bootloader. So I might as well use a board like that. One that's already kind of like a pain not ready to go off the bat. To be my... Because I bought a bunch of boards that didn't have the bootloader installed when you bought it. Not that you can't install it, it's just a... You know, it's an extra step. And so I might as well use that board than a board that's ready to go. So I have those in my closet. I'll have to go get that. And what I'm going to be doing is removing the microcontroller from those boards and then using this bootloader enabled microcontroller wired in this fashion to a board that has no microcontroller on it. And the system will be tricked into thinking that this microcontroller, which is just wired up in this configuration to the board, is the microcontroller of the board, when in fact it's an external microcontroller that we're just using the board as an interface to talk to. We're basically just using the board for its USB conversion kit so that we can talk to this with the board as a middleman using our computer. That way we can tell this what programs to install onto it, with this board with no microcontroller on it as the middleman. Once this has our program, we're good to go. We can do whatever with it. So we have to do this wiring configuration next, which incidentally looks very similar to the wiring configuration we just did. Interesting. And I want to do the whole thing over again from scratch because I want to save my existing configuration I just spent a lot of time on to be my permanent wiring for installing bootloaders onto microcontroller chips. I haven't eaten, it's my bedtime, so that's why I don't have to feel bad, even though I'm really enjoying this, guys. And you have to admit, I'm running into a lot of success here. I really, for a beginner who is very unsure of myself, whether I could pull this off without something screwing up, nothing went wrong. I literally wired it all up perfectly, followed the instructions to perfection, and installed the bootloader. First try. No screw-ups, no nothing, no magic smoke. You really can't beat that. So yeah, I'm a happy camper here. The next major electronics project for me will be to desolder my microcontroller from the bootloader installation wiring, which is very similar to the wiring I'll be using to use an Arduino with its microcontroller removed to talk directly to my new bootloader installed standalone microcontroller in order to upload programs to said microcontroller using the Arduino's USB to serial chip, FTDI chip or whatever. So basically it's going to just talk to our microcontroller as a middleman between our computer and our microcontroller. So the first thing I have to do is desolder my existing microcontroller from the bootloader installation wiring. Then I have to create all of the wiring, which is very similar again, to wire it to the Arduino for program installations. Then I have to desolder from the Arduino its microcontroller so that the Arduino thinks that the ghetto soldered on microcontroller is its microcontroller. And then we can upload our sketches as usual, or upload our programs as usual. They're called sketches for the Arduino environment for whatever reason. So anyways, yeah, and well, I'll eventually be getting my DIP28 sockets to replace the need to solder my microcontrollers in the future. So I'm going to put all my deadbug wiring into a socket, and then I can just plug and play to do all my bootloader installations and programmer installations into my microcontrollers. So that'll make things real quick. So yeah, those sockets are important. I did order them today. I have 10 of them on the way from China. They should take about a month to arrive. Although there's no drastic hurry, they're just going to make life a little easier. Save me a little bit of soldering. When I'm working with 100 microcontrollers for my robot project and various other projects, that will really be a good headache saver. But right now, when I'm still just working slowly and figuring things out, it doesn't really matter that much about saving a couple of seconds, or more like 10 minutes.